Hello everyone, welcome to Team 11's Senior Capstone presentation. Our team consists of 4 members: Austin Reule, our lone computer engineer, followed by 3 electrical engineers: Justin Richards, Levi Zelaski, and Brad Adams. Our team was tasked with creating an effective wire tracker alongside Duke Energy.
This project came around by the need to organize and track wire spools across the Cincinnati area. Many spools are used around the city with various cable sizes. While a whole spool is not used at each job, this causes the dilemma of how much cable is left on each spool. This can cause a lot of confusion for the crews that are using the cable. These crews have to waste time and money by figuring out where the spools are and if there is enough cable left for the next job. With our device, crews will know where the spools are, how much cable is on them, and what type of wire is on the spool by simply logging onto a website. This will save the company time and money by having all the information they need in a matter of minutes.
The proposed solution to our initial problem is a cable tracking device that is capable of being attached to the cable pulling truck in the spool. It would track the total distance the cable covered and store that information. This will integrate Hall effect sensors on our board along with LCDs and software. That will be the hardware section of our project, and then there's also a software section to go along with it. Along with the device, a separate application will be made to enable workers to upload and then view relevant information such as the last location used, amount used of footage of cable, a unique ID of the spool, and a couple more functions in a database that will be on Excel. This data transmission will be complete via Bluetooth to make the life of the workers simpler, and so it's time efficient.
Hello, my name is Austin Reule, and I'll be going over team roles, budget, and the Gantt chart for our wire tracker senior design project. Starting with team roles, we have Brad Adams as the project lead. He was responsible for keeping the project on track and making sure that we got all of our required documents in on time and made sure the creation and testing of the device stayed on schedule. Next, we have Justin, who is the mechanical lead. He was in charge of finding the device and the device housing, along with all the other sensors, LCD displays used in the device, as well as creating the overall schematic for our wire tracker. Next is me. I was the software lead. I was tasked with creating the Arduino code that would be used to connect the sensors and the LCD display to the Arduino, as well as be able to connect the device output to an Excel spreadsheet to display the amount of wire used. Finally, we have Levi, who was the electrical lead. Levi was in charge of putting the whole device together. He soldered wires for the sensor and LCD to be connected to the Arduino. Moving on to the budget. First off, since the project was a collaboration between us and Duke Energy, they were the ones funding this. So at the beginning of the project, we had budgeted about $1,000 to spend on the equipment, but as you can see, we only used about half of that. First off, the Arduino itself cost around $40, and then the 2 different enclosures used both cost $60. And to be able to power the device without connecting it to our laptop, we needed a battery housing, power brick, and that cost around $100. And then for the sensors and the magnets that were used detecting the rotations, that ended up costing $150. And finally, the LCD display that was used set us back $40. This came out to $450 total for the entire project. Lastly, we have the Gantt chart. This was a timetable for our entire project from design and construction all the way to testing. Starting from September of last year, we were able to start the board development, which consisted of ordering their Arduino and finding the correct sensors and display that would work with that Arduino. When we finally got some of the equipment in, we started the device construction and software development. These were done in tandem because the connections on the actual Arduino need to be correct in the software side. So we needed to set those up at the same time for the device to be able to work. About a month or so after we started the construction, we started developing a website that would show the results and overall development progress of the device. And then after finishing the device construction, we moved into testing. The testing took a little longer than we expected, mostly because we had to rely on Duke Energy, and we had to go on site to when they were pulling cable to be able to track it. And sometimes the schedules didn't always work out, and sometimes they just didn't pull at all. So that just took a little bit longer than expected.
The schematic of our device was drawn by Justin Richards after we went through and selected our components. The reason why we selected the components that we did was because the device itself does not need to be very powerful, as it basically tracks the revolutions of the spool. All real calculations will be done in Excel after that information is imported into it through Bluetooth, making our device require a very low amount of memory, very low processing power, and thus making the power draw very low.
Project flow. The wire spool will begin to rotate. Our device will then detect which direction the spool is rotating via Hall sensors. Our device will count the amount of revolutions that the spool completes. This value is displayed on our device. This value is then sent via Bluetooth to a company device to be entered into an Excel database. The final values are calculated and logged for later access, such as the length of wire used and the length of wire left on the spool.
Our testing of the device was broken up into 4 key phases. Phase 1 consisted of our basic testing needs, ensuring all our wiring, code, and mechanical devices were working as they should. Phase 2 was a small scale test in which we tested our device on a small residential size spool of wire to prove our concept. Phase 3 was full scale with Duke Energy in the field. This is shown in the pictures in the middle of the poster. Phase 4, the final phase, was used to fine-tune our device for the needs of Duke Energy.
The results of our project is as follows. We were able to accurately track the amount of cable that was being used through our mathematics. Our devices communicated via Bluetooth, and we were able to automatically populate this information into a database.
Our completed device is shown here. As we take off the back cover, you can see the internals of it. First is our board that does the tracking of the revolutions. The next is our LCD that will display the amount of revolutions and any other relevant data to the crews and the users operating it. After that, you can see that our wires coming out of the device are to 2 Hall effect sensors. These Hall effect sensors will link up with magnets on the cable pulling spool and track the amount of revolutions. This device right here is the Bluetooth chip so that we can transfer the data to Excel so that Excel can do all of our calculations for us. It's a very small and compact device that will make it really easy for the crews to use in the field and not get in the way.
Thank you for tuning in, and feel free to reach out to any of us with any